I'd like to take you through to briefly describe what we go through in a nutshell as far as the product development. First of all, there has to be a concept. And that concept is bred from all the input from our customers, from our pro staff, from all the history of the previous product. As we assemble all of that and we put together the look or the direction that we want, we end up with a set of conceptual drawings many times that we can look at and we can pick and choose from. So whether it's a desire to create a better coating for a trailer, and that's how road armor came about, or whether it's an all-new product line like the Z Project, it involves a lot of people and a lot of disciplines. Once we decide on the conceptual drawings and kind of the general theme of what we want the product to look like, we end up going then to the computer and solid modeling that product. And we have a solid modeling software and a computer design software that really allows us to look at these products on the screen. And that gives us some advantages because we can look at this project, we can turn the product, we can look at how different components fit within each other. Another thing that we can do is what's called finite element analysis. And that simply is a computer program that will allow us to stress these before they get off the computer screen. So what we end up doing is, with the database that we've been building over the years, we've found that we can simulate rough water or areas that would normally be an issue in hull development or stringer construction, and in many cases find out that either confirm what our suspicions were or to cause us to go back to the drawing board to develop it in a different direction. So it's invaluable information, but it's never a substitute for a hands-on for the people who have been involved in it from the very beginning, from people who have a real passion, who use the product, know what to look for, and have a real vision for what the future of Ranger will be. One of the things that we have at our disposal is a digitizing arm where we can actually reverse engineer. When we get a hull exactly the way we want it, then we can bring that back and actually digitize that part and then send it to the cutting machines and have digital information and history of that product as well.
We're taking this machine and we are recapturing this shape of this hull identically to within a very few thousandths of an inch, so that we can reduplicate this model again.
What you're saying is once you get it, you're digitizing, and that's what this machine is. Once this digital information is finalized, we're able to send that information to a 5-axis routing machine, which will cut that hull to the exact full-size shape. I've got a model here just for illustrative purposes to show a little bit of what that would look like, obviously in a much larger size. But that hull plug or that master will serve as the basis for pulling molds off of this plug, which the molds will then be used to build boats in later.
We're in the engineering shop now where these masters or the plugs that we've been talking about are built. The one that is being constructed right now is a deck or an interior, and of course this construction is all wood, and it's done that way so that we can shape or form this particular the shape that we want. The mold is all fiberglass, and the part that comes out of it is all fiberglass, but the structure that we use here to shape and form these various compound curves is, generally speaking, wood. This will be covered, and realize that this plug will just be the model for what we are going to ultimately end up with. This will in no way be used in the boat. It is just the master that we'll use to pull our molds from, and then the molds, of course, will have the parts pulled out of them, and that will ultimately be your boat.